Okay, in this video we're going to spend a few minutes to talk about the fundamental concepts of acids and bases. Now, usually when people talk about the fundamental concepts of acids and bases, when teachers say they're going to talk about the fundamental concepts of acids and bases, they're going to talk about the various definitions for acids and bases. Those are actually somewhat complicated questions because there's more than one definition for what an acid is and more than one definition for what a base is. So this video we're going to talk about even simpler concepts, and we're going to try to get to the real fundamentals, and the basic questions we're going to answer are we're going to try to answer these three main questions. What does it mean to say a solution is acidic? What does it mean to say a solution is basic? What does it mean to say a solution is neutral? Okay, and sometimes when I ask these questions, students will jump up and say, oh, well, this is really easy. When I say a solution is acidic, that means the pH is less than 7. If it's basic, that means the pH is greater than 7. And if it's neutral, that means the pH is equal to 7. Those are all true statements, okay? But what does that really mean? Students will say, okay, pH is less than 7. What does that mean? What does it mean to say that the pH is less than 7? And what I want to try to get to today is really visualizing what the heck is going on. What does it mean to say a solution is acidic? What does it mean to say a solution is basic? What does it mean to say a solution is neutral? In very kind of concrete terms that we can kind of wrap our minds around, okay? Now, before we answer these three questions, unfortunately, there's one tricky little concept that I need to address because it's going to talk about the notation that I work with in that video. And that one tricky little concept is the difference between the hydrogen ion and the hydronium ion. The hydrogen ion, H+, the hydronium ion, H3O+, okay? Some books, some teachers like to use the H+ ion notation, some like to use the H3O+ ion notation. They are, for most purposes, they're basically the same things. They're basically interchangeable. For this book and for this video, I am going to be using this notation, the H+ ion concentration. And the reason is it is easier to visualize. It is more easy to visualize what is going to visualize what's going on. Okay. Now, technically, it is inaccurate. Technically, the H+ ion does not exist in solution. The second I put an H+ ion in solution, it's instantly going to bond with a water molecule and form this thing right here, the hydronium ion. So the hydronium ion is technically more accurate. Nevertheless, even though that's technically more accurate, we're going to talk about it in terms of the hydrogen ion. It's a lot easier to visualize without having to add in that extra step. Oh, by the way, it bonds with a water molecule and forms this. It basically works the same. For your calculations, it should work the same, so we're going to go with just the H+ ion concentration. Okay, now with that out of the way, let's get to answering our basic questions. Okay, to start talking about acids and bases, we need to start by talking about water. And to do that, I'm going to sketch out a little glass of water here. Okay, just like that. Draw a little glass of water. And ask myself, well, what is in that glass of water? And the answer is pretty obvious. It's a lot of H2O molecules, right? It's a lot of little molecules of H2O. That's what H2O is. Like this, H2O is water, so my glass of water has a lot of these little molecules in it, a lot of H2O molecules. Well, let me ask myself, is that the only thing in there? Is H2O, when I have a glass of distilled water, is H2O the only thing in there? Or are there other things in there as well? And the answer is there are other things because of this. Anytime I get a lot of water molecules together, anytime I get a lot of H2O molecules together, some of them are going to do something called dissociate. Okay? And dissociate is basically a fancy word for saying that they are going to split. These molecules, these H2O molecules, some of them are going to split into an H+ ion and an OH- ion. Okay? Now, comparatively, this is a very small number. It is very few of these water molecules are going to do this, but nevertheless, some are. So when I look at my glass of water, I don't have pure H2O. What I really have is I have mostly H2O, but I also have a few floating around in there, a few of these H+ ions and a few of these OH- ions. Now, the H+ ions are referred to as hydrogen ions. The OH- ions are referred to as hydroxide ions. So that's what I have here. Even though I have mostly H2O, I have a few of these hydrogen ions and a few of these hydroxide ions. Okay, So now that we understand this, now we can get to kind of our fundamental question of what is an acid, what is a base, okay? If, and let me erase this all out here, try to clear this up a little bit. If the concentration of my H plus, the hydrogen ions, is equal to the concentration of my OH minus ions, which are my hydronium ions, if the concentrations are equal, it is neutral. Okay? That's what that means. A neutral solution is when the amount, or my concentration, to be technical, my concentration of H plus ions is equal to my concentration of OH minus ions. It is neutral. Now, do they always have to be neutral? Is it possible for me to have more of one ion than the other? Yes, it is. And if I have, let's say I do something to this, and for some reason I have more OH plus, more H plus than OH minus, then it is acidic. An acidic solution is one where the concentration of H plus is greater than the concentration of OH minus. Okay, well, if it's possible for the concentration of H plus to be greater than the concentration of OH minus, is the opposite true? Is it possible for me to have more OH minus than H plus? Absolutely, it's possible. And if that is the case, we say the solution is basic. Okay? So that's really our fundamental concepts of what's going on with acids and bases. Acids and bases, we need to understand is, anytime I get a lot of water molecules together, some of those water molecules are going to split into H plus ions and OH minus ions. If I have equal amounts of H plus and OH minus, it's neutral. More H plus, it's acidic. More OH minus, it's basic. One last little thing here, a little trick question here. Okay, we associate H plus with acids and OH minus with bases. That is not to say that acids do not have OH minus, and it is not to say that bases do not have H plus. Okay? Acids do have OH minus in them, and bases do have H plus. I'll do this sometimes with students. I'll ask students I'll give them a particular acid and say, tell me what is the OH minus concentration of this acid, and a student's hand will shoot up and say, trick question, trick question. It's an acid, so it has H plus instead of OH minus. No, that is wrong. That is a trap question. Acids don't have H plus instead of OH. It's just that they have more H plus than OH minus. Acids do have OH minus, it's just that there's more of the H plus. Likewise, bases do have H plus in them. There are H plus ions in bases, it's just that there's more of the OH minus. The OH minus, which is also referred to as the hydroxide ion, the bases have more of the hydroxide than H plus. But it's important to remember that bases do have H plus and acids do have OH minus. Okay, well, that's it for this video. I hope you find that a little bit enlightening to just hopefully you'll understand the basic fundamentals of what I mean, or what when your teacher says somebody, or you're reading a book, or somebody says this solution is acidic or this solution is basic. Hopefully you'll be able to have a little bit more of a concrete idea of what that means.